Hi everyone, so welcome to video 2 of the Unit 8 Day 3 notes about composite figures. So in part 1 we did problems 1 and 2 and 3. So now we're starting with problem number 4. So let's read through this. A water glass can be modeled by a truncated right cone, a cone in which is cut parallel to its base, is shown below. So here's our cup, and here's our cone that this cup was cut from. So the diameter of the top of the glass is 3 inches. So I already wrote that in. The diameter of the bottom of the glass is 2 inches. And the height is 5 inches. So remember, height, I'm putting that in the middle. It needs to be perpendicular to the base. The base with diameter of 2 inches must be parallel to the base with diameter of 3 inches in order to find the height of a cone. Explain why. So I just kind of said why. Base and height are defined to be perpendicular to each other. So if this is perpendicular here, and then over here I have another perpendicular, and now you look at these two lines cut by a transversal. These are corresponding angles. So if corresponding angles are congruent, those lines are parallel. So if corresponding angles are congruent, then lines are parallel. All right, so that part's done. Determine and state in inches the height of the larger cone. So this was like part 1. Part 2, determine and state in inches the height of the larger cone. Okay, so we need the height of the larger cone. So we are going to need, this whole value. I don't have really any measurements over here. But what we do know is some measurements from from this cup here. So we have, this is the hard part of this question. You've got to kind of think about this. How are we going to find the height of this cone? We know that much is 5, right? This much is 5 inches, but we need the rest of this. So this now becomes difficult. This is our missing section from right here. This part I'm coloring in red. We don't know what that is. Now, I do know this piece right here is half of that diameter, so I know that that is 1 inch. And this piece right here is half of that diameter, that's 1.5 inches. But again, how are we just going to solve for x? So I'm starting to see some shapes in here. I am seeing a large right triangle. My triangle looks terrible. This is 1.5. And from top all the way down, this length is actually x plus 5. And then I am seeing a smaller right triangle here, down here. This side is x, and that is 1. They both have a right angle in common. They both have that bottom angle is the same in both due to reflexive. It's congruent to itself. I have 2 similar triangles. And if I have 2 similar triangles, I know I can set up a proportion comparing their corresponding sides. So if I take the 1.5 radius and put that over the 1 radius, and then the x plus 5 for the length of this whole side compared to x, I now can solve for x. So cross multiply, 1 times x plus 5 is still x plus 5, and then 1.5 times x gives you 1.5x. I want to solve for x. I want to get all variables on the same side of the equal sign. I know there's an invisible 1 there. So 1.5x minus 1x just gives me 0.5x. I'm going to divide both sides by 0.5. So x is the value of 5 divided by 0.5, which is 10. So that is the height of the larger cone. Is 10, and all of my units are in inches. So that is the answer to the second part. Determine in state in inches the height of the larger cone. All right, so that was part 2. We have a follow-up question. Determine in state to the nearest tenth of a cubic inch the volume of the water glass. All right, so the volume of the water glass. It is just this top part. So we don't have a volume formula for a cup. We don't have a volume formula for that. But we do have a volume formula for a cone. So what I am going to actually have to do is take the volume of the big cone and then subtract the volume of the small cone. So using my reference sheet, cone, here's my volume formula. I'm going to write down 1/3 pi r squared h. And then this is going to be a minus 1/3 pi r squared h. All right, so for the big cone, I have my 1/3, my pi. I need the radius of my big cone, which is 1.5. I need the height of the big cone, which we found in the second part of the problem was 10. Then I'm subtracting 1/3 pi. Now I need the radius of the small cone, which is 1, and the height of the small cone. Oh, I messed this up. The height of the small cone is x. That's 10. Messing up all over the place. This is 10, but the height of the larger cone is really 10 plus 5. This one should be a 15. My bad. So one of the heights is 10, the other height is 15. All right, so let's type all this stuff in. So I have 1 divided by 3 times pi. And I forgot my squared. Oh my goodness, this problem's turning out to be a mess. All right, so I need that times 1.5 squared times 15. So this is the volume of the first cone, the bigger one, so I'm going to go up 4 places. All right, then the volume of the smaller cone, 1 divided by 3 times pi times 1 squared times 10. That is the number 10.471. Actually, it's got to round up to 20. All right, so subtracting these, 35.3429 minus 10.4720, we now get a volume of 24.8709. It wanted it rounded to the nearest tenth, 24.9. All the units were inches, so it's inches cubed. Volume equals that much. All right, so sometimes volume questions are really hard. You have to rely on other learning and past learning to figure things out. All right, so have a great day and have fun working on the day 3 homework. Bye.